All right, so we're going to begin today with decimal review and continue into long division. I think the main thing that we need to do with decimal, to review your decimal math and also to go over things to do when you're teaching decimal math, is to concentrate on decimal place value and concentrate on decimal division. And just a little bit of decimal multiplication. Really though, how much review do you think we would need on decimal addition and decimal subtraction? Really not a whole lot, because the borrowing is the same. All we're doing is expanding, I think. But we do have to cover the decimal place value, and even rounding and writing numbers behind the decimal point can be a problem area. The decimal system is introduced in 4th grade, maybe a little bit in 3rd grade, not very much. They do dollars and cents, so I suppose technically that's a decimal. But 5th grade math and 6th grade math, right where we're dealing with here with intermediate math, is the decimal system. So even though decimal is just an expansion, decimal math is just an expansion of whole number math, it needs to be treated as kind of a brand new concept because of place value behind the decimal point. So let's look at decimal place value. Introduction to decimals in your text is section 3.1. So as far as teaching decimals, terminology, nothing really new with terminology, but in facts, we do have to learn the decimal place value, but more important than that is for you to understand how the decimal place value works. What is place value? What is it based on, literally? Yes?
Powers of 10.
Powers of 10. It is literally on base 10. So every place in our place value system is an exponent or a power of 10, beginning with the ones power. Now, if you the ones place beginning with the 0 power. Now, if you took algebra, you learned the exponent law for 0, correct? That any base to the 0 power equals 1. You also learned in algebra that negative exponents mean to take the reciprocal. Negative exponents are behind the decimal point. So decimal place value behind the decimal point is still base 10. We'll just go 10 thousandths, okay? And the other thing with this is the tenths place. This is the hundredths place, thousandths place, 10 thousandths place, etc. So first thing for us is that you have a thorough understanding of decimal place value as it relates to powers of 10, then an understanding of decimal place value as it relates to fractions. And then I want to, so 1/10, 1/10, 1/100th, 1/100th, 1/1000th, 1/1000th, 1/10,000th, 1/10,000th. Unfortunately, how do we usually read this number? 0.01. Okay. That's necessary at times because you have to have a way to distinguish these verbally, correct? But we should use the 0.01 only when we need to distinguish that number from its fraction form and its decimal form, when we need to distinguish the two. Because with our decimal place value, we need to teach it as a relationship, teach the relationship to fractions. That's why we have tenth, the TH, because it is a different way, another way to express a value less than 1, and it is another way to express a fraction. So tenth, hundredth, thousandth. So this needs to be tethered to the fraction idea. But then some students would try to read this as a 1th. I even had a 7th grader do that in, I think somebody was missing some decimal place value. There's no such thing as a 1th in the fraction section. Think about it. We wouldn't read this 5/1. We would know that that's equivalent to the whole number 5, correct? So we have to make sure that we understand decimal place value, first of all, as powers of 10. Also, the idea of reading it in fraction form. So decimal place value is simply, for you, an expansion of your whole number place value. So reading and writing numbers now have to be a part of your decimal skills. And the other thing I want to go back to is place value on both sides of the decimal point. We did this a little bit in primary because we were working with basic place value. So we need to make sure that we have our basic place value down. Let's take this number here, 3,452 and 36, what? 36,000th. So in front of the decimal point, we divide our larger numbers into periods, where we group our numbers ones, tens, hundreds in the units period, then ones, tens, hundreds in the thousands period, then ones, tens, hundreds in the millions period. So behind the decimal isn't really a period, but it is read the same. We read this as it stands alone, 36 thousandths, okay? So when you are teaching 5th grade math, 6th grade math, 7th grade math, 8th grade math, even 4th grade math, do not read that number 0.036. Always read it 36 hundredths, okay? You're going to tell the students, and they will probably already know eventually, that it's 0.036, but the only reason I would do that is if I was distinguishing it from this. All right, and so in this context, do I ever need to distinguish it from its fraction form? No, so don't. It's 36 hundredths. So we have to teach our students to read decimals behind, numbers behind the decimal point by reading the number as it stands alone and adding its place. 36 thousandths. Can get a little that decimal is read 31,456 hundred thousandths, right? And here we can introduce the 0 exponent place rule. And this goes along with place value and reading and writing numbers. This number here is written in what's called standard form. It's written as a number in standard form. We can also write it in, get rid of this, we can also write this in expanded form, showing the value of each digit. This is 3,000 plus 400 plus 50 plus 2 plus, oh, there's different ways we could write this. What's the value of this 3? 3 hundredths, and I'm out of space, plus 6 thousandths. That's expanded form. We go digit by digit and give its value. This 3, the first 3 has a value of 3,000. The second 3 has a value of 3 hundredths. Then we can also write this in exponent form. We can write this in exponent form. In exponent form, what's the value of this 3 in exponential form? Yes?
10 to the third power?
Yes. Remember, I erased it, but we're dealing with the 0 exponent place rule. This has 3 zeros behind it. So it's 10 cubed plus 4 times 10 to the second power, or 10 squared, 2 zeros, 2 as an exponent, plus 5 times 10 to the first power, 1 zero, first exponent, 2 zeros, second power, 3 zeros, third power. What about the 2? How many zeros behind the 2? There aren't any. First power, or 0 power. All right, what about the 3? We've got 2 zeros, correct? But where are they? In the denominator, so this is then three zeros in the denominator, -3 exponent. 2 zeros in the denominator, the exponent is -2. This is the 0 place exponent rule. And this, yes, we know that our place value system is on base 10. We know that each digit is a power of 10, so we can easily write this in exponential form. That illustrates the fact that our place value system is on base 10. Each digit is a power of 10, quite literally, okay? And that now extends behind the decimal, numbers less than 1, those zeros are in the denominator, okay? So then the exponent follows the same 0 place exponent law. Okay, so each digit is a power of 10. So we have 6 thousandths, 6 thousandths, and 6 thousandths. Okay, so decimal place value in general is on base 10. Each place in our place value system represents a power of 10. 10 raised to a particular power, and the 0 place exponent rule works every time. For example, back here, where is the 6? This is especially how the place rule is going to help us when we're behind the decimal point. The 6 is in the 3rd place behind the decimal place, so it has to have the 3 zeros in the denominator. 6 thousandths. Of course, when you get a number like this, what's that? 3 and 5, what? 10 thousandths. 1, 2, 3, 4 places behind the decimal point gives me, this would be 3 times 10 to the 0 power. So then this is going to be 5 times 1, 2, 3, 4, -4th power, because this is 5 10 thousandths. 10,000 has 4 zeros behind it, correct? Okay, so even the ones place fits the exponent laws, and then all of the digits fit the exponent laws, because negative exponents mean to reciprocate the number into the denominator. So we would reciprocate 10 to the -2 as 100 in the denominator, 10 to the -3 as 1,000, or 10 cubed in the denominator. So make sure you understand decimal place value. Are you going to show 5th graders the exponents? No. But you are going to give 5th graders the idea that this is 3 places behind the decimal, so it's 3 zeros in the denominator. We may not deal with the exponents, probably shouldn't, but you can use the 0 place rule for numbers behind the exponent. 3 places gives me 3 zeros in the denominator behind my 10. So introduction to decimals involves being able to read and write decimals behind the decimal point, understanding what each place still means a power of 10. 7th graders have to use the exponential form when we're doing decimals in 7th grade, and we start really bringing home the idea of what the decimal point means. So you need to be able to read and write and expand numbers that include decimals. All right, and as we are talking about reading decimals, this is required. And you need to always write decimals that do not have a whole number. You need to always have a 0 hold the place of the ones place. Hold the place of the whole number. That 0 holds that place. Don't write this. Why not? The decimal is going to get lost. We emphasize the place value. We emphasize the decimal by having a 0 hold the place of the whole number, or hold the ones place so that we don't lose the decimal. That's proper decimal protocol. Okay, and so you will have to enforce proper decimal protocol. How do you enforce decimal protocol? You write it, they write it that way, and if they don't do it in their homework, you start docking their grade. Same thing, you have to enforce unit protocol. You should never accept story problem answers that are in feet without the feet. Okay, you'll notice on your homework, I will dock your grade if you don't answer 24 and 5/10. Or not 5/10, you'd never say that. 24 and 5/8 miles or inches or feet, okay? So make sure from the very beginning that you yourself are reading your decimals properly, that you yourself are writing them properly, and so on. So we always read them not 0.012. We read them at 12 thousandths. We always hold a 0 in the ones place and make sure that our students do that as well. So we need to be able to read, write, and also round behind the decimal point. Fifth graders have to do a lot with the decimal system. That's when the decimals become one of their main topics, is grade 5. And so we have to start from scratch with grade 5 somewhat and teach them to read and write and round and practice this. Practice writing it, practice reading it, and then understanding what they're doing so that when it comes time for the next decimal lesson, when we have to round behind the decimal, we're not having problems. Okay? The first time I taught 5th grade math, I come to the decimal rounding section and I make a big mistake. I assume that since they're in 5th grade and that they know how to round numbers, that rounding behind the decimal is going to be a quick flyby review. How did my homework go that night? Not very well. I was surprised. I graded the homework and some of them missed half of them or 3/4 of them. They were just rounding wherever, and it puzzled my mind. So remember, as a teacher, even in intermediate, yes, you are expanding their rounding from in front of the decimal to behind the decimal, but that's not going to work very well if you just do a quick flyby, like I'm doing with you guys right now. Okay? So make sure when you're teaching decimals that you park on the place value, you park on the rounding so that your students can expand their whole number knowledge and their whole number rounding to behind the decimal point. So rounding behind the decimal point, does it change? No, but for some reason, because it's in unfamiliar territory, 5th graders have trouble rounding behind the decimal point. So don't say, oh, there's no difference between rounding behind the decimal point and what they've been doing since grade 2. 2nd graders learn how to round. All right, there's no difference. Well, you and I know that. But for some reason, behind the decimal is difficult, I think because they're a little weak on their place value, not because they don't know the rounding rules. So when you are teaching decimal place value, you've got to keep hammering it. You've got to incorporate it into your drill. You've got to incorporate the reading of those numbers properly into your drill, into your review time, into your classwork, into your board work. Because their lack of understanding of the decimal place value is going to show up in the next lesson or two down the road when they have to round. And apparently it's because they're not finding the correct place. Because I know they know the rule about 5 or more round up, 4 or less drop, okay? And they also have to be trained that they don't need zeros. They need to be trained when do they write a zero and when do they not write zeros, okay? And they need to practice reading behind the decimal. They need to practice reading the number out loud behind the decimal. They need to practice rounding the decimal and so forth. Even though the rounding rule involving the 5 does not change, for some reason we have trouble with it, and it's got to be because of the weakness in the new place value. So we need to drill tenths place. We need to drill hundredths place. We need to drill thousandths place. We've got to make sure that our 5th graders have that decimal place value down much better than you think. Okay, so we've got to learn the place value, and then we practice reading and writing, and then we'll be able to round. If we're weak on our place value, who knows what will happen with this answer. Okay, and then we also have to deal with whole numbers. Once we start dealing with math behind the decimal and then mixing it with numbers in front of the decimal, make sure you teach them the idea that, let's say I have the number 31. To you and I, we know the decimal is here, whether it's written or not. It's understood to be behind the ones place, correct? But what do you have to do with that? You have to teach it, okay? Because the decimal place value is pretty much brand new in 5th grade. So decimals are a big part of 5th grade math, so we want to give them the attention that they need. Because even though you don't think twice probably about rounding behind the decimal, they will. Even though they've already rounded behind the decimal in the context of dollars and cents. And this is something that has to be deliberately taught. Sometimes, what if I had this instead of add the dollar sign? Sometimes we're so automatic, we know that's 13 cents, but we have to teach them to round to the nearest cent. Okay, I've also had, I've had 7th graders rounding to the nearest dime instead of cent. And I have to tell them, that's a dime. I want a penny, okay? So every detail that you teach on a new concept, even if they're 5th graders, and even if in reality you are expanding your whole number knowledge and your whole number math, because you are expanding them behind the decimal. But we can't treat it that way. We have to treat it as new concept, new procedures, and make sure that we spend time on them. Because we may not have to think twice when we're doing decimal math or decimal place value. They will have to do it, and you will have to read it, write it, round it. Of course, in the time that you're teaching, read it, write it, round it in drill time, read it, round it, write it as review on the board, even when you're down the road from the lesson and so forth. So the theme here is pay attention to decimal place value. Understand yourself the idea of base 10, but make sure that you are covering all the little details. That includes the 0 holding the place of the whole number. All right, and that includes reading it properly, no 0.125. It's 125 thousandths. All right, because a few lessons down the road, you're going to have to start relating it to fractions. And if we've been reading our fractions correct all along, how hard is this to convert to a fraction? It's easy. It already kind of is a fraction. All we have to do then is reduce it. So if we're reading this as 36 hundredths from the very beginning, converting a decimal to a fraction is just practice. Okay, otherwise they're going to say, well, how do I convert a decimal to a fraction? Well, forget about it, because we're used to calling that 0.36. So we have no idea. We have to remember some procedure. Not if we know that that's not 0.36, that's 36 hundredths. And if we read it right, all we have to do is write it in a different manner. 36 hundredths, 36 hundredths. So don't go the 0.36 route. It's going to cause you more work and confusion later. So converting from a decimal to a fraction is easy because place value is based on powers of 10. And that's hundredth. Okay? So you shouldn't have to teach students specifically how to convert a decimal to a fraction. You shouldn't have to spend a lot of time teaching students how to convert the other way. Because if we teach fractions properly, we teach our decimal place value properly, it's just a matter of format, not a matter of some procedure I have to remember. You don't want to be teaching your students to rely on their memory, do you? All right, remember. There we go, remember. Memorization is what? It's a poor teaching tool. Don't rely on it. It might be an emergency stopgap, but it's not a teaching technique. All right, memory is very short term. So we want to make all these connections and teach our decimal place value from the beginning in the correct way, and then this will be easy. I know that many students were not taught that way by the infamous math placement test. We have college students who can't remember, listen to how I'm phrasing this, they can't remember how to convert a decimal to a fraction. There's no reason to have to remember how if we understand how the system is set up. Okay? Do you remember how to change a fraction to a decimal? No, you should understand that this symbol is 5/8. Whoops. Let's fix that. Isn't it? But it's also 5 divided by 8, isn't it? And in the next few sections, we're going to be doing ratios, rates, and proportions. So this can be read and represents 3 different things. It represents the fraction 5/8, it represents the division problem 5 divided by 8, and it represents a ratio 5 to 8, or 5 to 8, or 5 out of 8. And then the next logical step is that it can also represent a percent, right? It's just that you've got your fractions, your decimals, and then the next logical step for 6th grade is to be able to write that same value in percent form. If we take an easier fraction, such as 4/5, this represents the fraction, let's see if we can draw something even remotely close to even. Not too bad. Okay, 4/5 would be, this is a little off, I'll fix it. 4/5 would be 4/5 of the circle, right? But it's also equal to, oops, 8/10, isn't it? Which makes it equal to 8/10, which makes it equal to 80 hundredths. Oh, this is what percent means. Percent means out of 100. So then 4/5 is 8 tenths, is 80 hundredths, is 80%. There's a very easy relationship between the three. So in 5th grade, we are starting with this relationship. Or maybe we should include this. Then if we establish that relationship firmly in the minds of at least most of the students, then the next step is easy. To take the next step and be able to write it as a fraction, also being able to write it in decimal form, and then being able to write it in percent form. So this is 4/5 of the circle, isn't it? It's also 8 tenths of the circle, and it's also 80% of the circle. So all of these types of numbers are not individual, where we do fraction math and we do decimal math and then we do percent math. They're all related to each other. And the decimal system, teaching decimals, is a bridge between fractions and percents. So we want to concentrate and spend due time on decimal place value. And we want them to understand how it works. Then we're not going to have trouble rounding. We're not going to have trouble converting to fractions. And eventually, then we're not going to have trouble converting to percents. Because percents is out of 100. Percents is the hundredths place. Okay, and the terminology dovetails together nicely and so forth. So from the very beginning, we want to establish a good foundation in our 5th graders with respect to the decimal place value. Then we can expand, and then we can understand concept and not have to remember years later how to do something, how to add decimals, how to convert to a fraction, how to convert to a percent. We're building foundation of math skills. And I've said before that success is understanding, because you're not going to remember. So we want to, as much as possible, reach the understanding, understand the background of how the decimal place value is set up, and then it's easier to expand it and retain it for years down the road. So when we're doing our decimals, you're going to be doing the chapter 3 review, or you already did it probably, but the place value is important. It's just not an exercise in doing math so that I have something to grade. Okay, so make sure that you yourself understand the decimal place value, so that when you, or if you teach around 5th grade level, or if and when you homeschool your own children, that you can do a thorough job on that decimal place value, because that's going to be the foundation of the rest of arithmetic, is understanding place value. Because by the time you start getting in upper arithmetic, you don't pay any attention to the whole numbers anymore. You don't separate whole numbers from decimals. They're just all the same as having a number. You're still going to probably separate the fractions out, but not the decimals and the whole numbers. All right, so rounding behind the decimal point is critical, and let's review it for just a minute. And then I also want to talk about zeros again. Zeros behind the decimal. If you took physics or some upper level science, you probably had fun with significant digits, right? And significant digits actually can be very much related to rounding. So in teaching the 7th graders what significant digits were and which number was more precise than the other, I know in high school here we do precision versus accuracy. Well, it's in the 7th grade book, math book now. It's in the 8th grade math book, and I'm kind of wondering why the 9th and 10th graders can't do it and don't seem to recognize it. That's because we never reached their understanding about it. So significant digits, I used to think were a pain in the neck too, because it seemed to me that the rules about when a zero was significant, do you guys know what I'm talking about? Do you remember having trouble with it in physics and chemistry and physical science? and getting your answer docked because you had too many significant digits, or you had too many digits and some of them weren't significant? Well, significant digits is based on zeros and rounding. With significant digits, you probably remember that all whole numbers, or all regular digits, all number digits, they're always significant. The problem with significant digit math, when you have to do precision, is when does the zero count and when doesn't it? If you remember, if you think about the rules about your zeros and the rules about rounding behind the decimal point, it's going to dovetail perfectly with the significant digits. And once I figured that out, when I started teaching 7th grade math, I thought, this is why this zero is significant and why it's not significant. Otherwise, I'd have 9th graders, what are they doing? They're trying to remember the rules, right? How well does that work? It doesn't. It might work if you study the rules the night before, but it's not going to work when you get to the test and you have all these other things to remember. So we don't want to have to remember the significant digit rules. We want to understand where they came from. And actually they came from rounding rules behind the decimal and writing zeros and when you don't write zeros. So think about this zero. Do you have to have that zero for any purpose other than procedure and formatting? Do you? Is this zero necessary when you are answering in decimal math? Is it necessary? No, it's protocol, right? Are these two numbers the same? So this zero is protocol. It has no meaning. Is it significant? No. And you probably were taught that in significant digits that zeros in front of the decimal point are insignificant, right? And if you start relating the significant digit rules to the place value rules and to the rounding rules with decimal math, they dovetail very nicely, okay? So now I don't have to try to remember. Every year I'm going to be teaching the significant digits and the precision to the 7th grader. All right, and then probably every other year I'm going to be doing a similar thing in 9th and 10th grade physical science. So I no longer have to study my significant digit rules because I understand them, okay? Otherwise, what do I have to do in physical science the night before? I've got to look over and make sure that I cover all the significant digit rules, and then I have to make sure that I'm enforcing them and doing them correctly. Well, that's not going to happen to me anymore because I'm still experiencing the idea that success is understanding, not memory, okay? So this zero doesn't mean anything, okay? What if I see the number 50? Do I know if it's been rounded or not? No. So do I know for sure that that zero is really there? I don't, right? So this zero is not significant. How can I know that it's really there? Morgan, you know?
There's a decimal.
If the decimal's behind it. All right, so let's say then let's just take the number 49.65. I'm going to keep the numbers a little big here. At this point, how many significant digits does this have? 5, because all numbers are significant. The problem comes with the zeros. All right, so if I tell you to round this to the nearest tenth, what are you doing? I'm sorry, tens. The nearest tens, no TH. If I tell you to round that number to the nearest tens, you're going to write 50, correct? So how many significant digits does this have? 1. It's exactly parallel to how you rounded. If I tell you to round it to the nearest ones, which would be here, right? What would you write? You probably would still write the 50, but you're not correct, are you? you need to put the decimal there. Then I know that this is rounded to the nearest ones. Okay? But, listen for a second, is it accurate, or not accurate, is it precise to the nearest ones? No, because I had to flip over and go to the 5. Okay? What if I told you to round to the nearest 10th? You would do, whoops, you would mess with the 5. And that's obvious that that's precise to the nearest 10th. What happens if I go ahead and do all these 9s? And I tell you again to round to the nearest 10th. What do you have to do? You have to go all the way to the same 5, don't you? All right, so then you would end up doing this, wouldn't you? So, does this 0 have a purpose? Yes. It tells you, when you read it, that, oh, I'm supposed to have it precise to the nearest 10th, but because of the 9s, I can't. So that's a significant digit, isn't it? Okay? That's a significant digit because we deliberately put that decimal point there, right? So, this is precise to the nearest 10th. This is precise to the nearest ones. This is precise to the nearest tens. So it's all based on precision and whether or not those numbers have a meaning. What if I have this? And I'm asked for significant digits. If those zeros are there, they're there for a reason. So they would be significant if they're written. Because normally, would you ever put all those zeros back there? No, so when zeros are deliberately placed, they are significant. And when they're not, they're not. Okay? And if you think about it from the rounding rule standpoint, it's going to help you. And so what I have to do in 7th grade math, when I'm teaching decimal rounding, I have to make sure that when this decimal is there, it has to be there. When this 0 is there, it has to be there. So when the directions tell my 7th graders to round this number to the nearest 10th, and they write 50, what should I do? Dock them. Say, well, this isn't really any different of a number. Yes, it is. Okay, and then if I in the rounding chapter enforce the proper use of the 0, I'm going to have less trouble when I get to the precision chapter 2 sections later. You see how teaching works? So if you have a good curriculum, there's a couple of things that you want to not do. You don't want to assume that they know it and assume that the lesson is unnecessary. And you also don't want to leave things out unless you know for sure it's not going to come back to haunt you later. So if I'm not really concerned about teaching the zeros to my 7th graders when we're rounding in chapter 5, the decimal section, it's going to come back and I'm going to have a really hard time. It's actually section 7.6, the precision. Okay, had a hard time with it. All right, because some of them still did not catch on about this and so forth. You're going to have a hard enough time anyways. So don't set yourself up for failure by assuming they know things and so forth. So when we are dealing with decimals, for us as college students and for us here in teaching intermediate math, don't ignore place value. Okay, and make sure that you yourself understand it, understand about the zeros, when you write them, when you don't, when they're necessary, when they're not, and the fact of making sure that you don't assume they know those place values behind the decimal. You've got to Teach them, drill them, practice them, because decimal place value is kind of brand new in 5th grade. And they're going to need it, and if you skip over it and say, oh, they know that, I'm going to get busy on the addition and the subtraction and the real math here. No, don't skip the introduction sections, cover them thoroughly. Because I'm actually going to do the opposite. I'm going to fly by addition and subtraction very quickly. Because if you understand the place value system and you already understand the law of addition, you're not going to have trouble with addition or subtraction in the decimal system. What is the law of addition? You can only add what? Like quantities. So now if we go into the addition of decimals, many times textbooks will call this number a mixed decimal to help relate it to the fact that this, if I were just to say that verbally and you only saw it, or only heard it instead of saw it, could you see tell the difference between the two numbers? 3 5/10, 3 5/10. Okay, so we are now going to be dealing with adding and subtracting mixed decimals, and it's going to be just like mixed numbers. Okay, and we are going to obey the law of addition. You can only add like quantities, and it doesn't matter if we're in 3rd grade and we're learning about not adding like unlike units, or we're in 4th grade and learning that we can't add unlike denominators. Now that we're in 5th grade, we have to learn that we cannot add unlike places. We have to have the same unit when we're doing measurements. We have to have the same denominator when we're doing fractions. And now we have to have the same place when we are doing decimal addition and also decimal subtraction. So we want to tether some of this. All right, it's true that if I'm adding 5 3/10 plus 12 plus 6 25/100, that I have to add the ones place to the ones place, the tens place to the tens place, and then that 12 is a whole number. It's not a mixed decimal. I can't stick it on the end. So I have to, when I do my addition, I have to decimal justify. Understood decimal behind the 2 in the 12. Otherwise, I will get this. I've gotten that this year on multiple occasions from one of my 7th graders. Okay? I did do a decimal addition flyby in 7th grade. Okay? Because it should be a simple expansion and a simple review of the law. But if we don't know the law, it hasn't been pointed out to us, and we've just been taught how to add fractions, and we've just been taught how to add decimals, we're going to miss some of those things, and we're going to make really dumb errors like that one. So when we are adding and subtracting decimals, we have to align the places, and so we are going to decimal justify. We are not going to right justify like we do with our regular numbers, because a whole number, you right justify, that automatically lines the ones place up. That's not true with decimals. So we are going to decimal justify. This is a crutch at the beginning. It's not too bad of an idea to keep all the places aligned and so forth, especially students when they're copying it out of the work page. Okay? So be sure that you decimal justify. And then anytime we teach subtraction, what do we need to center in on? Anytime, whatever grade I'm teaching. What? Borrowing, yes. So we have to watch out for this. What's the danger of borrowing all the time, whether it's decimal math or fraction math? If we're going to do it here by accident, we're going to do it here also. Never bring down the subtrahend. What do we do with fraction math? We borrow in terms of the denominator. So here, we don't have to worry about that, but we're going to borrow a 10 because this is powers of 10, places of 10. So do not allow them to bring down the minuend. That's why it's not a bad idea to make them put the zeros on the addition problem. Then they'll put the zeros on the subtraction problem, and it's going to head things off. But the law of addition, which also applies to subtraction, so we can only add or subtract like quantities. We can only add, in this case, like places, and of course subtract like places. All right, so as we're doing the decimal math, center in on place value. Make sure that you understand place value and the idea of base 10 and then the expanded form. What's the next step after we teach 7th graders how to write things in expanded form using decimals? For example, 31.2 is equal to 3 times 10 plus 1 times 10 to the 0 power plus 2 times 10 to the negative 1 power. What's the next step after this? Why are we bothering? It does help them understand place value, but what's the next step? What are we laying a foundation for? Scientific notation. Yes, scientific notation. Okay, and scientific notation is taught to 7th graders, and it's taught even further, it's taken even further to 8th graders. Then when we start doing some math in 10th grade especially, and then in high school, in chemistry and physical science, when we're dealing with, and even in biology, when we're dealing with very small numbers in biology, very large numbers in chemistry, we don't have to teach them the blind rules of how to write something in scientific notation. They'll already be used to that idea of the times 10. They'll already be used to the idea that each place I move my decimal changes my exponent, right? And then we're building a foundation for things that are coming in the future. So keep that in mind, even when you're teaching 5th and 6th graders. You're laying their high school foundation. It's important when you're teaching 1st and 2nd grade, you're laying their arithmetic foundation. But always keep in mind what's coming next for them. So that should be one of your goals, is to prepare your upper elementary, your intermediate students for their high school math. So it's not enough to get through the textbook. It's not enough to be getting good grades. It's laying foundation and actually learning math and instilling math skills. So with the decimals then, we need to be doing everything in our curriculum as much as possible. If it's a good curriculum, if it's a good textbook, everything in there is there for a reason, okay? And so this expanded form in the 7th grade book is there for a reason. The significant digits precision section is there for a reason. So if at all possible, I'm not going to skip. It's not always possible, but I'm not going to skip that. What about multiplication of decimals? I'll use the word beauty, even though it sounds kind of flowery and whatever. But the beauty of multiplication is not governed by the law, is it? So with multiplication, do we decimal justify? No. And one of the biggest problems with the 7th graders, because kind of teaching the 7th grade has helped me to see what's not happening in 5th and 6th grade, right? Or at least not what's not happening in that student, what didn't happen in that student when they were in 5th grade and 6th grade. And so what I'm seeing sometimes in 7th grade is that students will decimal justify with multiplication. Is that necessary? So if I am going to go back to that illustration with 12 plus 3.5, does that apply if I'm doing 12 times 3.5? No. I do not decimal justify when I am setting up my multiplication problem. I just do it. Actually, I would probably do it this way, because I like having the smaller numbers in the multiplier and the larger numbers in the multiplican. And actually those names don't really have any meaning because they're both factors and it doesn't matter which one's which, does it? So do we decimal justify with multiplication? No. But do we ignore the decimal? Of course not. So when we do our decimal multiplication, there is no law. Do we get a common denominator with fraction multiplication, like we do with fraction addition? No. So we have to keep multiplication separately and realize that we don't decimal justify. We'll have students do it. I have students do it. It really doesn't hurt their answer, but then they add zeros and they make this big mess, and then they have all these zeros in their partial product, and then they wonder why their decimal's out of place in their answer, because they added all this extra unnecessary things. So when we do basic decimal multiplication, you can see why I like having the 1 and the 2 in the multiplier. Don't have to do a whole lot of carrying, and I know that 2 times 35 is 70, and 1 times 35 is 12. I mean, 1 times 35 is 35, looking at the 12. Okay? And then there's 1 decimal in the problem, so there has to be 1 decimal in the product. And this is where estimation comes in. Basically, what do I have? I have almost 4 times 12. 4 times 12 is 48, so it makes sense that almost 4 times 12 is 42. Estimation is an important decimal skill because the answer here is not 4, is it? And it's not 420, it's 42. Okay, so estimation is another skill that we're not going to want to ignore, especially with decimals, even with whole number math and so forth. We'll talk about estimation in and of itself. So then multiplication of decimals does not require decimal justification because there is no law governing multiplying likes only. But then we always have to cover all of our bases. You can see the textbook has this problem. 37 thousandths times 8 hundredths. Okay, so I do my right justification. This gives me 56. 24 and 5 is 29. But this is 37 thousandths times 8 hundredths. Can we ignore the denominator? Can we? No, this is going to be 296. How many zeros we got? 1, 2, 3, 4, 5. 10 thousandths. So don't you think my answer's got to reflect the place value? And it does. So I have 1, 2, 3, 4, 5 zeros or places here. So 5 places here because I have to get 296 hundred thousandths, whether I do it in fraction form or decimal form. So that's the why behind the how. All right, we will see you on Tuesday.